Hello everyone, and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer, released in 1991. It's been a while since we last spent some time parsing files, so for today's episode we will parse the sound files, Duke1 and Duke1b.dn1, and we'll convert them so that we can use them with Java's built-in audio library. We will then play sound effects for the various events in the game, such as jumping and shooting. Alright, let's make some noise! And we are back at the moddingwiki shikari.net website, where all the Duke Nukem files are described, and the inverse frequency sound format file is also described there, where the PC speaker sound effects are being stored. Now this is a sound format that is being used by a lot of the classic Apogee games. You know, it contains the sound data for all of the various sound effects that the game has to offer. And yeah, we'll just use this information to parse the sound file. Now, how the games usually do it is, as you can see here, that they ignore the header and the sound names as well, and they just have hard-coded sound numbers to figure out the sounds. So, and I think we'll do something similar as well. But yeah, for Duke Nukem at least, we have Duke1.dn1 and Duke1b.dn1. So let's just start with reading in those files and see where we go from there. So let's go to our resource loader and let's go right below here. So let's start with a public void, because we don't have a data type yet, but we'll have one soon. But let's start with a void, read sounds. And yeah, let's start with those two. So we have Duke1.dn1 and we have Duke1b.dn1. And yeah, we want to loop just each of those two files and read them like we do all the other ones. So let's have a random access file and let's do everything how we used to do it. So let's resolve a file and we want to open it in the read-only mode. And this might throw an exception, so let's do that. So we have IO exceptions that we can say could not read sounds with a cause. Okay, and yeah, like we said, we will skip the header. So let's just skip 16 bytes here. And yeah, so that's this header here, so we don't really care. And then next up we get some header information for each individual sound. So, and yeah, what we will do is normally you would have to know how many sounds to read in, and we can see here that the number of sounds are actually in the header, but since we're ignoring it, we probably have to guess a number. So at least for now, and then as we read in the file, we'll figure it out. So let's yeah, 63 is apparently a regular number, so let's just read in 63. So let's start with I is 0, I is less than 63, or 64 I guess, since 63 should be inclusive. Okay, and then let's just read in these different definitions for a single sound. So I'm just going to copy it over here to see it. And yeah, we first start with the offset, and it's a unsigned int of 16 bits. So we want to convert the short that we're reading to an unsigned int at least. And then here we want to just read in a short as usual. So we want to reverse these bytes here, in.readShort. So this is the offset where the sound data is living for the sound that we're reading in. We are interested in the priority. So that is 8 bits. So that is a probably short.reverse bytes. Oh, we don't have to reverse. We can just read an unsigned byte. This is the priority. And then next is the rate, defines the update rate of the timer, usually set to 8. So we'll just skip it. Probably not interesting. And then the name. Now the name is usually ignored as well, but just to see if we are actually loading this stuff up properly, let's just read in the name real quick so that we know that we're on the right track. So bytes is new byte, and it's 12 characters reserved. Then we can say read bytes, or just read in the bytes. And then we'll take the name. It's a new string bytes, and we want to trim it because it's null padded, so that means that it's always 12 bytes. So if there's less bytes being used for the name, we want to just drop the white space at the end. So let's trim it. And yeah, let's just print out these names. So yeah, let's print a name. And yeah, let's run this and see if we're at least reading in the headers properly. So let's just go here and let's say l.read sounds, and let's see what that leaves us with. Let's switch over here and then run the resource loader. All right, so we have a lot of garbage, but here you can see a lot of nice names until we get to dot and ffff and stuff. So I'm guessing here, walking. So how many lines is that here? So let me just add that. So it's 340 to 362, so that's 22. So let's read in at least 22 sounds instead of 64. 23 then, because we want it to be inclusive. And then, yeah, let's check it out here. How many files, how many proper sound files are here? I guess let's include unnamed. I'm not too sure if those are actually needed. So we get 40 to 363. So I'm guessing these unnamed are not too important, so let's just also read in 22. That should give us all the proper files, all the proper sounds. So that's 23 sounds per file. Okay, so now that we have that, what we can do is we can parse in the sound data because we have the offset and the priority. So let's first make a class to actually store this stuff. So let's make a sound, and I guess we should make a sound package as well. So we have sounds.sound. So we have a private priority, and we'll probably have like some sort of raw data that represents the sound wave. Get priority and get data. And yeah, we're not really interested in the name. At least not while playing the game. We might be interested in the name while reading, so I'm just going to keep it here. All right, so let's see. What we want to do is we want to have the current file pointer, because after reading in the sound data, we want to go back to the current position so that we can keep on reading these files. And then here, we want to go to the offset. That's defined here so that we can start reading in the raw sound data that is accompanying the sound that we're reading. So how we will do that is we will keep track of a value that we're reading in. Because let's open up the sound file definition. The sound data is divided into words, so the 16-bit unsigned integer values. And then you can calculate a frequency value here. We'll do that in just a second. And then here you can see that the value FFFF signals the end of a sound. And most values are between 100 and 5000 hex values. And then here, this is also pretty important, 0 is silence and will cause the PC speaker to be turned off. So that's probably a special case that we need to handle, because obviously if you read in a value of 0 and then you divide, you know, this frequency by 0, you're going to have a problem. So let's first read in this value. So let's do that while we have a value that is not FFFF. So let's do the same stuff here. So let's read an unsigned in with some reverse bytes action. And as long as this is not 0FFFF, then this is more data for the sound. And then, like I said, let's calculate that frequency. So let's copy it over from the documentation. So that's this thing right here. So the frequency is this divided by a value, but only if a value is not 0. Is value of 0, then we'll just say that our frequency is 0 as well. All right, let's go back to our documentation. And yeah, so here, in order to convert to actual sound data, we need to use this this sound rate here at 144 Hertz for Duke Nukem. What we want to do is we want to convert this raw data into like sound data, because Java cannot access the PC speaker, so we cannot use these frequency values to just send it to the PC speaker at a certain rate. We need to actually convert it to waveforms for Java to process. And what we'll do is we'll just use the sinus wave, so we'll calculate some angles with the values that we're reading in here to calculate some bytes here and there. And we'll do that with some simple math. So let's see, we have the frequency here, so let's calculate the amount of samples that we need. So let's see, we want to have an integer, and we want to divide, so 1 second, 1000, divided by the 144 Hertz that Duke Nukem uses. And then let's use some sort of sample rate. So 44100 is CD audio quality, that's pretty usual. All right, so this is the amount of samples that we gotta store. And then let's make a byte array for that one. So let's call it data, I guess. Is new byte with the amount of samples in there. Guess we can just inline this here. So we'll just make a buffer here that holds in all the values that we're going to calculate. So if the frequency is 0, then just fill that array with nothing. So this is complete silence. Otherwise, we want to calculate a period. And this is, again, our sample rate divided by the frequency. So that's the period of our sine wave here. And then let's loop for all the values in our array, calculate the correct position in our sine wave. J is less than the length of the data buffer. So this is just generating all the values in a sine. So let's calculate the angle. So each sound wave, each sine wave, should I say, is 2 times pi. And then we want to do times j divided by the period. This high school math here. And then we just want to write that value into our data buffer. So data j is the sine value of the angle that we just calculated. And we want to multiply that by 127f to make it fit a byte range, because bytes go from minus 128 to plus 127. And I think we need to cast this, cast a byte. All right, so that is the raw byte data converted into a sine wave that Java can hopefully play back for us. Yeah, so let's write this to a, so we need to here keep track of the whole array. So let's just do a byte array output stream here, because each value that we're reading here will lead to an X amount of samples depending on the sample rate. So here we want to add these bytes that we've calculated here to that complete data buffer. And then once we are completely done, we want to create a new sound with the priority that we've read, priority, and the full data that we've read in this while loop here. So let's keep track of all the sounds here in a list. So list sound. Sounds is a new array list. And then here we can say sounds.add new sound with the priority and the byte data, and then seek current is then go back to the list of sounds to process the next one. All right, and then here, once we're done, we can say return these sounds, and then our void can become a list. All right, so let's still keep printing these names here. So let's just keep like an index plus the name. And let's see if reading in all these sound files actually work. Okay, so we get a end of file exception. And it looks like that happens when we try to read in one of these unnamed files. So what we'll just do is we'll skip unnamed files. So if unnamed equals the name. So if we have an unnamed file, then just skip it. All right, so this reads in all the files. So we have file 0, player death, get food item, Coke can hit, enemy shot, box explode, player jump. It's number 13. It's pretty cool. All right, so now that we can read in these files, these sounds, I mean, we should have a way to play them back. So yeah, let's create a new class, the SFX class. Now, like I said earlier, Java cannot write to the PC speaker, so that is why we've been doing this elaborate conversion here to, you know, sine wave data. Because Java has the audio system, and the audio system is capable of playing back audio, obviously, for sampled audio, and we are generating some sampled audio. So what we will do is we'll try to get a line that you can write data to. And then if we write the data to that line, then the audio system will play it back. So can we open up this line? So let's see this line info here, open, close, controls. And then let's just see what types of lines do we have. So we have a data line. And we probably need to have the source data line, because a source data line is a data line to which data may be written. And that is exactly what we need, because we need to write the raw data that we've been reading in the resource loader to this data line. So a source data line is what we need. All right, so let's keep track of a source data line in this class. So let's make an init method to set this up. So line is AudioSystem.get source data line. And now audio format. I guess we need to instantiate some new audio format. So the sample rate, what we said was 44100. So I'm guessing I should just make a public static final int sample rate. CD quality might be a bit too high, and let's replace that here as well. Should we want to change it, we can just do so. Okay, are there more places where I have 44100? No, okay, cool. All right, so here we can pass in the sample rate. Sample size in bits is probably 8, one channel. Signed, sure. Big endian, sure. Not too certain what these things mean, but I guess we'll find out. All right, so we need a try catch here. Could not initialize audio system or something, or SFX, I suppose. Okay, so that is the line. So we have to open the line, and we have to probably start it as well. Not too sure if opening also means starting, but whatever. I think doing it both is needed. But this probably also means that we need to shut it down. So let's make a shutdown method as well. Shutdown, line.flush, line.close. And then let's add the shutdown to our shutdown hooks. So runtime, get runtime, add shutdown hook, new thread, shutdown. This will make sure that the line gets properly closed when Duke exits the game. Okay, so this is probably going to play us back some sound. So what we need is actual sounds. So let's just have the list of sounds here for now. Let's make a constructor. Oh, that's the wrong constructor. Let's make a constructor that takes in the list of sounds. All right, and let's make a playback method. So I guess init, and then here public void play sound. We can see a list of sounds, so I guess we can just do index. And then what we can do is a line.write sounds.get index. dot get data, right? Yeah, and I guess I need to assign this to a variable, because here it expects an offset and a length. And we just want to write all the data at once, I'm guessing. So tell the sound system to play it back with this drain thing. Okay, so I think this should play back the sound in the data stuff. So yeah, let's go to Duke Nukem and let's initialize our sound effects. So here we'll just make a SFX class, and here we'll actually instantiate it, new SFX loader.read sounds. Cool. And we need to initialize it as well. So sfx.init to open up the line. All right. And I think what we need to do in order to play it back is have these sound effects available in the game state so that we can actually trigger some sounds. So yeah, let's just have SFX here, private SFX. Not too sure if the game state is the correct place for it, but for now it's the easiest to just get some playback here. All right, and then here I guess I'll just make a public void play sound int index, and then here you can just say sfx.play index. Okay, and then yeah, let's just play some sound when Duke shoots his gun, I suppose. Here, so let's say game state, play sound, and then we got a player shoot, player gun, sound number 6. All right. Oh, let's run Duke Nukem. And now let's see if Duke makes sounds, like if Duke's gun makes a sound. All right, so it sounds pretty weird. It's a bit muffled, I guess. So yeah, let's, I think it is because, let's go to the resource loader, because the PC speaker did not have very subtle sound waves. So a sine wave, like a proper sine wave, might be a bit too subtle. So I think what we can do is actually take like the full value. It's either minus 128 or plus 127. So it's either full on or full off. I don't think the PC speaker was capable of doing very subtle sound waves. So let's try again with this signum. Yeah, and this sounds a lot more stark, but this is how it used to be. So that's pretty cool. Okay, just for the time being, I think what we should do is keep the game state at the top level here and reevaluate if this is needed. But I think because what this allows us to do is just say like, hey, keep track of the game state at top level, and then we can go to Duke's jump method, because here we don't have the game state, and I would love to actually have the jump sound. So here we can say game state, play sound, and then should be a player jump 13. Okay, let's see if we can get the jump. All right, so in here you can see a small problem is that the game actually pauses to play the sound before continuing. Yeah, we can quickly fix that by having this the writing of this sound data to do that in the background rather than as a blocking operation. So let's do that, and let's also keep track of the priority. We don't do that yet either. So we need two things. So we need a priority, or current priority, I suppose. And let's initialize the current priority to like the minimum value, because a higher priority means we should play it back. And then here what we can do is we can check. So we need this one here, sound this. So if the current priority, if that is larger than or equal to the sound's priority, so I'm guessing what we should do is check if sound priority is less than, not less than, yeah, so that's greater or equal to the current priority. Then we want to play the sound back. And after the sound has been played back, we want to set the current priority all the way back to the minimum value. All right. And yeah, we want to do this in the background. So we want to have an executor. In Java, to do stuff in the background, you can have an executor doing it for you. And what we want is a single thread executor. Just need one thread because we only have one sound playing at a time anyway. All right, so here we have a single thread executor. And here what you do is you say, hey, executor, run this block of code for me. And now this will happen in the background. So now if we play the game and start jumping and shooting, the game keeps on flowing. All right. Yeah, so we have a lot of places where we can actually add sounds. I'm not going to do that in this episode. But you know, we got jumping and we got shooting, so you guys get the idea. It sounds pretty good. So let's do one more thing. There's a sound toggle, so we'll just keep track of if sound is enabled or not. And let's by default say that sound is enabled. And then we'll just make a method that sets toggle or something, where we say enabled is not enabled. And then in the Duke Nukem handle input, here what we can say, if key handler is pressed VKS, then we can say sound effects dot toggle, and we want to show a modal, new message modal or something. Which modals do we have? The ones that we just want to have, yeah, just message. Yeah, message that says like, so X tile size 48. And then this should say like sound is either on or off. Prompt sure. So here in SFX we can have an is enabled. And then in Duke Nukem we can say here SFX enabled, sound is on, or sound is off. All right, so and I guess I need to reset the key input. Key handler reset. Is there a way to clear? Clear. Okay. Sound is off. Sound is on. All right, I of course need to do something with that thing here. So what I should just do is, if we are enabled and if there's priority, then play it back. All right, let's go. So we can shoot, that makes noise. And then now sound is off, and let's jump, and there's no sound. All right. Okay, I think that about wraps it up for today. We've came, again, a very long way. Now, of course, we did not add all the sounds at all the spots, player death, bomb explode, box explode, whatever. Would be a bit too much work, but you get the idea. You know, you can just go to the game state and say like, hey, play this sound effect when this situation happens. And we'll definitely add these things at various spots, picking up items and all this stuff. But yeah, this was the very last thing that we needed for level 1 to be fully complete. Obviously, to be completely complete, we have to add these sound effects, but we'll do that. Don't worry. And yeah, for next episode, I think we'll go to the hallway, to the intermission hallway, where we will read the secret message in each hallway. And the hallway allows you to save the game as well. So we'll probably take a look at saving and loading the game. So yeah, hopefully you can join me for that one. If you like this episode, then consider dropping a like and a subscribe. If you have any questions, then of course feel free to put them in the comments down below. Thank you very much for joining me, and I'll see you guys next time. Bye-bye.